Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the occurrence of events. In the last lesson, we learned about simple and compound events and how to predict the outcome of a string of simple events. We also saw a tree diagram to predict the outcome of a string of random events. We learned about the nature of dependent and independent events, and we learned about the multiplication theory of probability. Today, we are going to learn about the classical, empirical, and axiomatic approaches to probability. If you are ready, let us get started. You remember during the last lesson how we classified a subset as a string of events. We can express rolling an odd number on a die as an event. Therefore, if we succeed in rolling a 1, 3, or 5 on one throw of a die, we can say that the event has occurred. We should also note that the complement of an event is made up of everything in the sample that is not covered by our favorable event. It's a bit like how a complementary angle combines with an acute angle to make 90 degrees. Now that we have a firm grasp on the nature of events and samples, let us learn more about the different approaches we can take to calculating probability. The first, called the classical approach, we have already dealt with. It makes the assumption that outcomes are mutually exclusive and equally likely. So it is fair to use this approach when calculating coin flips and die rolls. The empirical approach is better suited toward repeating an experiment many times. This is very important. If you only flipped a coin once, you might think the odds of coming up heads were 100%. Therefore, the probability of the event is the ratio of favorable outcomes in the experiment. The third is called the axiomatic approach. It is called this because it gives us an axiom, or a set of preconditions that we need to satisfy in order to solve the problem. First, we must define the term S as the sample space of a random experiment. With each event called E, we associate a real number we call the probability of E. This is denoted by a capital P next to a capital E in parentheses. This real number satisfies the following properties that we call the axioms of probability. First, the probability of E has a value either equal to or greater than 0 and equal to or less than 1. Second, if the sample space is equal to 1, that denotes a sure event. Third, if the first event and the second event are mutually exclusive, then the probability of either event occurring is equivalent to the probability of both events occurring. Fourth, if there is no probability of an event occurring, that event is impossible. This incorporates both the classical and the empirical approaches. Please make a note of the axiomatic approach, students, as it incorporates aspects of both of the others. It is time now for an activity, students. If the odds against an event happening are 5 to 7 against, what is the event's probability? Please try to answer this question together.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Let us find the answer to this problem together. We already know that the odds are 5 against the favorable event and 7 for the event. This means that we can add both types of events to find the total probability of the sample set. 5 and 7 make a sum of 12. If 12 is the total sample set, then the probability of the event occurring must be 7 in 12. Was that your answer? If it was, well done. Let us try another question now. I am confident you can answer it. Try to find the probability of drawing an ace from a well-shuffled pack of 52 playing cards. Please go ahead now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. This was a trickier problem, but we have learned all we need to know to solve it. Shall we do it together? There are 4 aces in a deck of playing cards. Therefore, our event space is 4, whereas our sample space is 52. Divide the total result by the common denominator, and we have our answer. The probability of drawing an ace is 1 in 13. If that was your answer, good work. This seems like an exercise that could have many potential uses in the real world, does it not? If you are ever playing cards with your friends, you will surely benefit from knowing the probability of receiving a particular card. That is all for the lesson today, students. This has been an introduction to probability theory. We have learned about the classical approach, the empirical approach, and the axiomatic approach to probability. We have learned to predict the probability of simple events. Soon, we will learn to solve challenging and fascinating problems with what we have learned today. Until next time, thank you, teacher. Thank you, students.